Hello everyone, greetings from Indians of Science. Myself Hardik J. Pandya. I am a professor here in Department of Electronic Systems Engineering under the division of ECS, and I am also an associate faculty for CPDM within the institute. Now for this particular course we are going to teach on advanced neural science for engineers. What does that mean, right? So you understand neural science, anything to do with your brain. And when we say advanced neural science, that means that how can we make a different kind of devices or you can say electrodes, right, or sensors that can be used for recording the signals from brain. Now when I say recording the signals from brain, what does that mean, isn't it? So you already know about the concept called EEG, electroencephalogram. But when you take the signals from the brain, that means there is a craniotomy, skull is taken out, and then you have a dura, and either you can take the signals from the dura or you open the dura, there is a CSF, cerebrospinal fluid, it comes out and you can see the brain. When you implant the device in the brain, then the signals are called ECOG, that means electrocardiography. So we will learn in this course how you can fabricate such kind of implantable sensors that can be placed in the brain and we can do recording in vivo, right. What does in vivo means? Within the body, right. So we will be looking at some of the micro engineering technologies. We will look at some experimental laboratories where you will be taught how to evaporate different materials, because for the device either it is silicon substrate or it is a flexible substrate which is PI, we need to deposit several materials, and for depositing materials you have to use techniques such as e-beam evaporation, thermal evaporation, sputtering. You have to perform lithography, which is a photolithography of how to pattern those metals and the materials. And then we will also look at how the different kind of PCBs as an interfacing board can be designed and developed. We will further look at the casing mechanism, because when you place the chip or implant the chip in the brain, you have to do a proper casing. So how 3D printing works, right. So that is a part of the additive manufacturing. So right from sensors to electronics to additive manufacturing and signal processing, and how to use MATLAB to do the post processing analysis, right. So this is the part. I am sure that you will be learning lot of skills, but some of the things at the end of this course you will be learning are how to fabricate implantable devices, how to understand ECOG signals, how to analyze those signals, how 3D printing works, how you can design different masks for fabrication, what kind of characterization techniques are used once the chip is ready. And of course on a overall how the different applications we can address, or the solutions to different gaps that we can find out using microfabrication technologies, and this solution and the gaps are related to the brain. So we will focus, our whole focus in this course will be towards the brain. Now when we talk about brain, we also understand that we will talk about certain diseases, for example epilepsy, which is commonly known as seizures. We will talk about Parkinson, we will understand that how the deep brain stimulation electrodes versus surface brain stimulation electrodes can be used, how the electrical stimulation can be given inside the brain, what should be the parameters. So all this is a part of this course, and I am kind of sure that you will enjoy the learning during the entire period of this course. We, as I have told you earlier, let me reiterate that we have several experimental laboratories where we record how these things are done, so you can actually look into the fabrication process as a whole. I look forward for your registration and interactions during this time. All the best. Bye.